Okay, welcome back to the channel. I'm glad I'm able to feature our first G07 here on the channel. Like I say, I haven't been able to come across any tubes in all this time, and then a couple of videos back where I got my monitor haul, I got a couple of them. So this is the chassis off one of those tubes, and I wasn't able to test it because the original flyback here had the anode cup was just basically completely disintegrated. So I wasn't even able to turn it on. So the first thing that I did was just go ahead and replace the flyback. So it's got a new flyback. And this resistor right here, you can see this resistor, I have replaced that resistor, but the original one that was in there was this guy over here. And as you can see, I did a quick visual inspection and I saw that these were just pretty much burned right in half. They were just burned right up in half. Now I don't even know what kind of contraption, jury rigging type of deal is going on here, but these were just burned or snapped right in half. And these were installed in this location right there. So I put a new one of those in there, got rid of these, and then along with the flyback, I went ahead and just turned it on, and it was completely, totally, utterly dead. 100% dead. It did nothing. So in that instance, we checked the fuses. And if we see here, I'm going to put the meter in continuity mode. We can check this main fuse here from the AC input, and that's good. If we check F901, it also checks good. You heard it, check good. But I'm making this, I'm doing this here as a informational video because it's not actually good. So in series here, you can hear I've got continuity on F901 here, but it's not actually good. If we go to ohms and we test our AC input fuse, you can see here that it tests, oh, stay on there, there you go. You can see that it tests 0.6 ohms, 0.4. So our fuse here is good. But if we go to F901 and test it, you can see here that I get no reading. It's out of limits. So in circuit, F901 cannot be measured correctly in a circuit through continuity mode. If you go to continuity mode, you'll have continuity. But you can see here that it doesn't actually have the same continuity as this fuse here. Any day now. There you go. See, there's 1 ohm. If we go back to 901, you can see it has continuity, but we have OL, out of limits. So you cannot test this properly in circuit. I mean, you can tell it's bad because if I go to the ohms, I get no reading. It's negative, out of limits. But this will read continuity in circuit because you're reading through other components. I haven't looked into it too far. But when you're testing the fuses on the G07 F901, you have to go to ohms and see if you get a, obviously if it's good, you'll get the standard reading of 0 ohms. So I mean, that's what you should be reading across F901. If you go across F901 and you don't read 0 ohms, it's bad. So you can't just do a continuity mode because you'll get continuity and it won't be good. So it'll fool you. So the first step here to proceed on is I think the fuse got taken out because these opened up or some type of vice versa. And almost all the time when F901 dies, it's either a voltage regulation problem or something over here, either the flyback or something in the flyback area died. So F901 will go much more often than the main AC fuse. So the first step here is to figure out really what happened with the fuse, because we don't want to put another one in and have it go immediately as well. But we're also going to have to clean this because it is super, super grimy and dirty and dingy. It's just really bad here. We got broken. See, this thing here is all disintegrated. It should be around. It should be over here. This one's disintegrated as well. I may swap some of these out with a parts one that I have, but it's just super, super dirty and dingy and grimy. So the first step here is we're going to go ahead and wash it and clean it. And when I come back, we can go ahead and do our troubleshooting to see if we can figure out, it's even got some type of fiber laying here. And the can's all rusty. So first step here is to kind of get this all cleaned up and washed and rinsed and back to looking good. We got glue laying on here and who the hell knows what else. This is more glue. So yeah, let's go ahead and get this all cleaned up and undirtied, if you will, and then we'll come back and see if we can troubleshoot as to why that F901 blew up. So I'm gonna cut away here, get this all cleaned up, and we'll come back and I'll have it ready to go, and then we'll do our testing. Yeah, I mean, even the fly back here, this thing was super nasty. It didn't, from what I can tell, it hasn't exploded. There's no melted points or burns or cracks or anything. I just obviously can't use it because this is chewed up and gone. So that's why I got taken out, or removed, I should say, or replaced. But yeah, this is a super dirty chassis. So let's get it cleaned up. I'll come back and we'll proceed with our troubleshooting, see what we can find. And just like that, we are back from the deep sink, and we have a nice new looking clean chassis to work with, and we are unhindered by dirt and debris and dust and dirt and debris and dust and dirt and everything else. So you can see it's much better now, looking nice and clean. Didn't get down in there too well, but that's fine. But a billion times better than it was, and now we don't have to worry about having all that crap and crud in our way, being able to take readings and test and things like that. So now we have this all cleaned up and ready to work on. And I have already removed F901 out of the chassis, which again resides right there. You can see right here is where it used to be, F901. And as we know in circuit, it was reading continuity. Well, not exactly, it was, you know, -0, negative out of limits. But as we can see here, if I touch my leads and we touch the fuse, let's go this way. And we touch there's our leads, here's the fuse, and open. Nothing. Let's touch the legs here. Got the legs here, and we got nothing. So it just goes to show that you can't, on the G07, is really the only chassis I've ever come across where you can't trust the fuse in circuit. So in circuit it read continuity, but didn't read any ohms. Negative out of limits. But the other main fuse was good, we saw. So just a good example there. If I actually go to ohms and try it again in ohms, we have nothing. So in circuit we had continuity, somewhat, but out of circuit we don't. So that's why it's important on the G07 here. You have to remove the fuse from the chassis in order to test it properly. And as we suspected, it's open. And if we look at it, it's internally, we can kind of see that it has seen better days. There's that yellow discoloration area where it popped, and it may look like it's a continuous path from one side to the other, but as we just checked, it's open. So that would explain why it's totally, completely, utterly dead. Usually you don't have, almost every time when you have a G07 that's totally dead, F901 is bad. But in order to test it properly, you have to remove the chassis from the, remove the fuse from the chassis, as we saw. So alright, so we have a bad F901. We had these resistors, these in series, or parallel, in these parallel resistors, I should say. These parallel resistors that exploded. And we got the new one installed, the new flyback, so now it's time to test. So the first thing we want to do is test our voltage regulator, and that's this guy over here on this side, the 2SC1454. So the first thing you want to do is check that to make sure it's okay. The easiest and quickest way to verify whether or not you have a bad voltage regulator is to just read across a B+ resistor. In this case, it's supposed to be a 220 ohm resistor. So if we read across the resistor, what do we have? 220. So our voltage regulator is most likely fine. The best way to test this is to touch the frame, which will put our negative lead in the screw head. And we'll touch the lead here on the voltage regulator, the pin here that runs to the, you can see that there's a pin here with the white wire that runs to here. So if we touch that one, it should be around 1.8, because we're reading through our resistor, 0.18, because we're reading through our resistor. Let's see here. Through our resistor to ground. 220, I should say, sorry. Oh, you know what? Sorry, diode checker. Herpaderp, that's why this is the amateur channel. There you go, 0.18. The other one should be our 0.5 voltage drop. And there you go. So our voltage regulator tests good. So that's not our problem. Let's check our HOT. Same scenario. We take our negative lead and touch the screw head, and each one of our two legs should be, that was the frame. Each one of our two legs should be 0.5. We got 0.45 and 0.45. So our HOT reads good as well. So if you have a F901 that's being taken out, it's not the voltage regulator and it's not the HOT, and we've put a new flyback in it. We've already replaced this resistor here. The next thing you want to do is check to make sure you don't have any cracks in the board. These boards are very susceptible to being cracked because the flyback is screwed to the side, and when you solder it in place and screw it in, it takes the flyback and tweaks it over, and you can get very minute cracks in the flyback, or in the around the area where the flyback is. So if we just examine this here, I don't see any cracked or broken traces. We can go ahead and check our continuity though while we're at it. We can go here to here, and then we follow this up to here. Let's see, up to here. Okay, so that pad's good. We'll go to 10 here and go to here. That's good, and then follow it through to here. Come on. There we go. 6 just goes to right there. 5 goes to here. 4 goes to here. 3 goes to here. 2 goes to there. 1 goes up to here. And it also comes down through to here. Okay, so we don't have any cracks on the flyback. Let's take a look here and inspect for broken solder joints or anything that is cracked that may leap out at us and say, oh, there's our problem. I'm just checking all these. These all seem okay. That diode is not looking too good there. Just going to hit that real quick. Right here. Okay. Let's go back and look through here. Yeah, I mean, I don't see anything that's cracked or broken that would leap out at me. So I don't think it's a solder joint problem. So I guess what we'll do is, I'm still waiting on parts here to show up. They should be here tomorrow. So I'm kind of making a preemptive video here. But HOT tests good, voltage regulator tests good, B plus resistor tests good. We can check this resistor down here. Should be 2 ohms. If we go to our ohm setting, this resistor here should be 2 ohms, and it reads 2 ohms. So that's not our problem. We can take our B+. I'm going to replace the B+ pot. I replaced the B+ pots on pretty much all of these that I've worked on in the past. But if we take it and just wipe it back and forth a bunch of times, your B+ should read about 120 volts, which correlates to around 160 to 170 ohms across the. It's a 2K ohm pot. So around 120 volts, when it's set properly, equates to around 160 to 170 ohms. So if we touch this lead and this lead, we're reading 6.5. So that's not good. That's not good at all. If we put it down, is it still 6.5? 326. Okay. I'm gonna just kind of preset this to 165. 122. Oh, come on. it's just so ever so touchy that it's hard to get this perfect. See, it's just, that's why I always replace these pots, because of how touchy they are. See, I can't even get to 100. I mean, you barely touch it. There's a 153. Well, I'll leave it there. Not like it matters, because I'm going to put a new one in it anyway. But usually around the 160, 170 equates to 120 volts when it's operating normally. So what I'll do here is I didn't see any bad solder joints. So it's quite possible we simply have bad caps that might be causing this. You know, like I say, normally when F901 goes out, it's almost always caused by either a bad flyback, something over here in the flyback area, or a bad voltage regulator. Very rarely will you ever have a bad B plus resistor or this 2 ohm resistor down here. And none of these other resistors look burned up. But what was odd was that this set of resistors here in parallel that was in this location that just got so hot they cracked right in half. That makes me wonder about what's going on here with this. So it may have just simply been that these failed. The old flyback was bad, which took these out, which then burned up the fuse. I can't say. So I obviously haven't tried this, because I had to order new fuses because I don't have any parts for G07s, because I haven't been able to work on them. So now that I finally have some, I went and ordered some parts. So they're not here yet. So I have new fuses on the way. I have cap kits on the way, flybacks on the way, other transistors and stuff. So the first step here, well, I keep saying the first step. This is like step number 5. We're going to have to wait until the parts arrive. We'll change the B plus pot out, get a new fuse put in it, get the caps replaced, do a nice full reflow. And if the fuse goes out again, then we'll see if we can figure out what else is going on, because you can see this resistor got a bit warm. This one here got a bit warm. You can't even read the numbers on it. These numbers are here, but this one kind of burned up. Let's go ahead and see what it reads here. I'm not sure what it's supposed to read, but it's reading 6K. I think it's 10K is what it's supposed to read. 12K. So yeah, I think this is supposed to be a 10K resistor. I can't say with 100% certainty, but in circuit it's reading 6.2. We can go ahead and let's go ahead and just remove it here. I'll show you. I'll show you here. Okay, so in circuit it's reading 6.2, give or take, once you let it get up there. 6.2. So I think it's supposed to be 10K. If we actually remove it from the circuit here, R421 that is, out of circuit, it reads yeah, 10K. So that resistor's fine. Well, it's actually 9.2, but that's not out of spec for operation here. Okay, I'm just trying to think if we should check anything else. The B plus resistor, the main. I got more glue falling off this thing. The main B plus resistor is attached to our F901. So let's go ahead and check to make sure that's. I think it's 4 ohms, 4.7 ohms is what this says. 5.0, good enough. So it's not that resistor. This resistor here, this fusible this resistor here, FR901, is a fusible resistor. This guy right here. This can get taken out and cause that fuse to go out. FR901. This is a fusible resistor, FR, meaning, you know, it acts like a fuse and opens up. So it should be 220 ohms, and I gotta wonder what it reads. 220 on the nosy. So that's not bad. It's just quite possible that we need new caps and a reflow, and it should fire right up. I can't say for certain. I think obviously the fuse probably went out because something happened with the old flyback, which took this resistor out, which took the fuse out. That's all it could simply be. Almost every time, like I say, the F901's going out almost every time. It's an issue with something in either the flyback itself, in the flyback area, or the voltage regulator. We've ruled out the voltage regulator. We have a new flyback in there. I've replaced this resistor for the ones that exploded. I think we're probably going to be able to get away with just doing a full reflow cap kit, replacing the fuse, and maybe it'll work. But there's no way to know without trying, so once my parts arrive, I'll come back here It'll be a day and a half for you, but I'm sorry, a day and a half for me, momentarily for you. And then when I come back, I'll have the cap kit done, the full reflow done. Then we'll go ahead and install the new fuse live on camera here, because I want to show, I don't think the fuses come with the leads on them. And I want to show you guys how to install the leads, because if you take a regular old fuse and try and solder to it, it's not going to work. It won't work. Don't even try. So what you have to do is get yourself the fiberglass scratch pen, and you scratch off the coating. There's a a polished coating on the outside of these fuses. You scratch off that polished coating, and you can solder to these things all day long with no problem. Now, you don't want to leave the iron on for maybe more than a couple of seconds, because there's actually solder inside the cap that secures this to the glass tube, and actually that the fuse inside of here will actually go to and solder to. So you don't want to leave it on there for more than a couple seconds, or you'll loosen all that up and you'll open up the fuse internally. But just kind of dab the iron in there and get a nice blob of solder, and you can solder a lead to it lickety split. And I'll show you how to do that once the new fuse arrives. If it doesn't come with these leads, the fuses I ordered are specifically for a G07 and F901, but I don't know if they come with the leads on them. So we'll find out. Hopefully they don't, so I can show you that, but I may end up showing it to you anyway. Okay, so also I'll change the B+ pot out too, so we can get it set properly, because these things are just so touchy that I just change them out as a rule of thumb. So yeah, let's go ahead and wait for my parts to get here. We'll come back and have the cap kit reflow B+ pot installed. Well, it's actually 4 days later from a moment ago from when I left you. I expected this stuff to arrive fairly shortly, but it took 4 days to get here because it got delayed. I had ordered a lot of this stuff prior to when I began the video from a moment ago for your point of view. But for a quick review here, we had a destroyed anode cap on our flyback, so I don't even know if this was good or is good. I didn't want to even try and bother to power it up with that like that. So that got replaced with a brand new one. And we also discovered that it was, what is it, R421 here. Someone had put a couple of resistors in parallel here, and it just basically heated up and disintegrated into two different pieces. So that was bad. So I got R421 replaced, and then we went ahead and I turned it on, and it blew the F901 immediately, gone. So that's when I kind of came on with the video here, because I wanted to see if I could get this figured out on camera so we can have our first G07 be a successful repair. So I have the filter cap out because I want to show a tutorial on how to change it out, because it's such a vastly different size here. It's a different footprint. So you'll see what to do. But after getting all the parts, I went ahead and did a full complete reflow, full complete inspection, and a full cap kit. Now on the inspection, I found that the horizontal frequency pot was kind of not really bad, but broken. You can see that it's this whole area here is jutting out. It should be flat against the back of the pot, so that someone shoved a screwdriver in here and pushed too hard and tried to adjust it. So not only is this kind of out of whack, I don't think this is an actual problem. I don't think it's an actual problem, but it's not supposed to be like that. And then someone has this turned all the way up. This is exactly how I took it out of the chassis. That's why it's important to inspect everything, because somebody had this completely turned up. Ideally, you want to have it, 25, 50, or 75. If it's all the way to one way or the other, that's not good. So having this completely all the way to the right could have been a contributing factor to what took out F901. Because if the horizontal frequency was way out of whack, it can cause issues like that. I've seen the horizontal frequency be adjusted way out of whack and cause problems like this. So I went ahead and just decided to go ahead and replace all of the adjustment pots. These are all brand new pots, and they're set roughly to center. Vertical hole, vertical linearity, vertical height, and horizontal frequency. So these are all set to roughly center. And then this is a brand new B+ pot as well. I went ahead and took out the old one, even though it was probably okay, but I went ahead and put a brand new one in. It's a 2K ohm pot, and I adjusted it to 170 ohms, which should be, give or take, close to 120 volts for B+, if we get this to fire up. And I also replaced the F901 here, and the new fuses do not come with the legs on them. They come just like this. So I'm also going to show you how to solder legs onto here properly. It's very easy, and doesn't take much effort, and it's something that I'm sure a lot of you would be wanting to know. So this is the way you should do it. I mean, people put a remote fuse holder in here, and that's fine too, but it's just as easy to install legs on this on this fuse and have it done the right way. So I do want to mention that I didn't find any bad solder joints per se, no bad joints. Nothing was cracked or broken, but almost every single pad had next to nothing when it comes to solder. All the solder joints were oxidized. None of them were shiny. Almost every single one of them had almost no solder at all. Like you breathe on it hard and the solder would crack or break. So I went through and reflowed almost pretty much 99% of every solder joint on the entire chassis. So a lot of bad, well, I don't want to say bad, a lot of suspect and very dull and a lot of no good solder joints. How about that? So we took care of the reflow, we took care of the full cap kit, we took care of the flyback, the pots, the new fuse. And I did want to mention that I also, R901, this funky looking box here is actually a resistor. And it's a 6.8 ohm resistor, and I removed this original one and put in a much more modernized part. It's this little guy right here, R901. And it's a 6.8 ohm resistor. It looks like a capacitor, but it's actually a resistor. And this is a much newer technological part, and it's able to kind of do a better job than this original part was. So I'm going to link down below the parts that I use for this whole rebuild. So if you get one of these and you want to try your hand at all this stuff, you have access to what the parts are. So I changed out the R901 as well. So I think what we're ready to do here is, I also replaced these broken or missing plastic pieces, or rubber pieces here, I should say, rubber pieces. I think it was this one here, this one, and this one down here that was broken. So I got those rubber pieces replaced as well. So basically everything that needs to be done has been done, except what I'm also going to do here on camera is I'm going to install. Oh, I also forgot to mention I did the curl mod. A lot of games on the G07, when you get it to sync up properly, the top of the screen will be curled, or sometimes the side of the screen or top of the screen will be curled over, and you can't really adjust it out with the horizontal hold or horizontal frequency. If you adjust the H frequency to a certain point to where it doesn't lose hold, and no matter what you do on the range of the pot, it's still curled at the top or curled on the side. There's a mod you can do, and it's very simple. It's like 3 steps. So there's originally a cap in this spot, C303. The cap, I'm sorry, no, C501. The cap that was originally in C501, you remove this cap and throw it in the garbage. It's no longer needed. Then you remove the cap that was in C303 and put it in C501. So this cap here was originally in this location here, C303. So you take out C501, throw it away, and put C303 from this location into C501 spot. Then you fill this hole here, you fill that up with solder, and you open up this middle hole that's not being used, and you install a 50 volt 22 microfarad cap in place of where C303 used to be. So you can see here it's silk screened for the location of an actual electrolytic. So you install this capacitor here in the location of C303 that has been moved to C501 in place of this original C501 that went away. And that's all you have to do to get rid of that curl. If you ever have a G07 here with the curl on the top or the side, that's the mod to get rid of it. And when you buy these cap kits from Peter at Arcade Parts and Repair, he includes instructions on how to do all that, and he includes that cap. So if you get if you get your cap kit from Peter at Arcade Parts and Repair, all that information will be included, but I want to talk about that as well. I wanted to mention that. So the only real thing left here is to install our filter cap. Then I also want to install this horizontal centering mod. You can see here, centering pot modification kit for horizontal centering. So basically, the G07 has another difficult issue to overcome where you can't get the image to be centered left or right. Some games where you hook it up, it'll be off to one side, so you try to adjust your horizontal frequency and it'll shift it over a little bit, but there's still a long black bar on one side or the other. So you move this horizontal centering post. There is a jumper here that you can move horizontal center. You can take this and move your H position over to the left, or move it over to the right, or leave it in the middle. And no matter what you do, if you want to move it over to the right and you move this over to this position here, and it doesn't quite move it over far enough, and you adjust your H frequency and it still won't move it off far enough, you still have a black bar, that's where this mod here comes into play, because this will allow you to use these pots to manually position your horizontal, well, position, just like you could for your horizontal hold or vertical position. You'll have an H position and a vertical height. There's not really a vertical position, but vertical hold will be able to do it. Vertical position also has a vertical sensor. So there's a mod here to do horizontal centering. Now, I haven't taken this out of the bag to find out if it helps with the vertical as well, but I'm digressing here. There is, under normal circumstances, there is a jumper that you would use to jumper the image left or right or up and down. Well, you can only jumper it so much. It moves like maybe 1/4 inch. So if you got 1.5 inches of black and you move this jumper and then you end up with an inch of black, and adjusting H frequency or vertical frequency won't do anything to move it to where it needs to be, you're going to have to get this centering mod and see if you can get this installed. So the first thing I want to do here before I do that mod is let's go ahead and just get this filter cap installed. It's been a long day. I've been in training all day for work, so it's been a long day. So you can see here that the footprint for these two caps is quite different. There's still a positive, let's zoom in here. There's still a positive and negative. These are the two pins here for positive and negative, and these two pins here don't do anything other than just provide an anchor point. This is such a big cap that it needs an anchor point on the board. Well, this one is minuscule compared to the other one. So what you're going to want to do is when you put this in here, you can see the negative line, or the dot indicates negative. If we look at the back side of here, here's the positive, here's the negative, and then here's the two support pins. So what you'll do is you'll take your positive here and put it in this hole right there. The negative is going to stick out, I think, this hole there. No, it's going to stick out the big hole in the middle. So it's not going to reach over to where it needs to go, quite obviously. So what we'll do here is we'll put this in here, and it's going to end up looking like this. And we can see that we have positive is now extruded through the hole here. There you go, our positive is through, but our negative is sticking out here in no man's land. And there's nothing for it yet. It needs to go over to here. Well, how's it going to do that? Well, we're going to put some component legs to jumper this leg over to here. And that's all you have to do. So the first thing we'll do is solder this in for the positive. Give that a minute to heat because of the large plane. Okay, that's not bad. I'm going to turn my fan on here, sorry. And let's fill up these holes here. Not necessary, but no reason not to. Okay, so now what we need to do is get ourselves a component. In this case, I'm going to use this capacitor here. And we're going to take a couple of leads and double up on our leads here. Let's see how long they need to be. Roughly, I'd say we'll go right here. So we're going to clip this right here. All right. Measure another piece and clip that. So we now have two, because one's not going to cut it. No pun intended. Zoom back out here a bit. And now we have a couple of component legs that we can use to solder this in place. Now, let's go ahead and tin our connector, or our leg here, I should say. All right. And we will get this guy, well, it's not. And there that went. Fantastic. Stay there. Okay. Alright, so one leg is not going to do the job that we need. And I dropped that other leg. I have no idea where it went. So we're going to have to make another one. And that's roughly right there. Okay. All right. Let's get this in place. There you go. That is how I do that. That's how you should do that. And you can clearly see there's plenty of separation here between our positive and negative. Well, I say plenty of separation, but that's my opinion. I think that's fine. It's not going to jump across there. So there you go. That's how I do it. Obviously, here's our positive, and then here's our negative to our ground plane, and that's it. So now we have the filter cap installed. Let's go ahead and mark it off here. That completes our cap kit. Now let's see about doing this centering mod. Well, you know what? Let's talk about the fuse first. Let's do a tutorial on this fuse. I do want to mention that none of the caps I took out were bulging. None of the caps I took out were leaking. They all looked fairly good condition, even though they're 40 years old, approaching 40 years old. I don't think those were the cause of our problem. I think we had some type of issue with the horizontal frequency pot being maxed out, and probably a bad solder joint or two. So now that we have that taken care of, let's talk about this fuse here. So if you try and solder to these fuses, you can solder and you can hold it on there and hold it on there and hold it on there, and solder will not absolutely flow to this in any way, shape, or form. You're going to end up heating this up so bad that the cap's going to come off. You're going to ruin the fuse. It's going to be just trash. So the easiest way to do this is scrape off the edges with your fiberglass pen, and the solder will stick to it immediately. You'll go from nothing to immediate. You can try flux, you can try whatever you want. You're going to end up just melting this cap right off of the glass, and it doesn't take much to do that. So the quickest and easiest way is to just simply use your fiberglass pen to remove the coating that's on both of these ends here. It doesn't take much, but you want it to be dull, and you want to see the scratches. You want it to be dull. You want to see the scratches in the edge here. See, that's not bad. So the same thing for the other side. You want to rough up the surface so you have something for the solder to stick to. And that'll do, pig, that'll do. So now watch and be amazed here as I put solder on the end of this fuse and watch it flow right onto it. Here we go. I gotta get the right angle here, sorry. There we go. Look at that. Beautiful. Absolutely beautiful. Now this gets really hot really quick because it's very thin metal, so you have to give it at least like a minute before you try and handle it. Yeah, it went right on there. It's also going to be difficult for me to try and do this. I don't have a holder because I'm cheap, and this is the amateur channel. So I take my deal of flux here and just kind of set this in here. Hold it. Yeah, see, it's still so hot it melted that flux immediately. This metal is so thin that it heats up super quick and stays hot for a while. Let's see if that helped. Okay, that's better. Alright, so now let's try the opposite side here, and you'll see just as easy how well this... There you go. Oh, you didn't see shit. Sorry, there you go. God damn it, sorry about that. Yeah, Perfect. I mean, less than a second you've got that on there. So with it sitting in there like that, what we're going to do is grab another component. Let's grab this one this time. And we're going to solder onto here for our leg. And you have to give it about 10 seconds or so before you try and move it, because like I say, it doesn't harden very quickly because of the heat and how thin it is. Now we will simply remove the flux from the end of our fuse here. Ah, damn, it's still hot, son of a bitch. All right. Now what we'll do is we will zoom out a bit here, and we'll grab this leg off of this, and we will use this as a prop here to see if we can. That's not going to stay. What am I trying to? That's not going to work, but we'll try it. All right. So ideally, you want to keep both the legs in the same orientation. So let's see if by some chance of miracle here, I'm able to actually get this to work and not move on me. There we go. And ladies and gentlemen, there's our fuse. Quick and easy, and as you can see, the solder joints are nice and shiny, they're nice and secure, and yep, factory fresh. So that's how you do this. You don't have to, god damn, that stays hot for so long. But as you can see, it turns out very nicely when you do it this way. So we got a brand new factory fresh fuse, and this will go in the next one when that time comes, because I've already got one replaced in here. All right. So speaking of which, I will show you. If you recall, I believe it was what, 4.2 ohms last time. I've got a new fuse installed here. I think it was what, 4.2 ohms in circuit when it should have been 0. So let's go ahead and test it now and see what it reads now. We're hoping to be 0. Okay, place your bets, place your bets. There you go, 1.0. Ideally should be closer to 0, but let's check F902. Come on. See, I had the same, 0.5 and 1. But we had 4.2 before, so and the fuse was open. Oh, there you go, 0.7. So now we have a known good fuse in there, and I believe we are, I mean, we could try it right now. You know what? I think what I'm going to do, let's worry about this later. Let's turn it on, see if it works. Make sure the fuse doesn't blow immediately. If it does, then I'm not going to worry about this until later. There's no reason to install it if we have a chassis that's going to be dead. Let's go ahead and turn it on now that we have everything done. I forgot to mention I left this case off of here, so you can see here underneath that we have IC501. IC501 is part of the circuit for your horizontal oscillation and other things. So if you have a G07 that's in shutdown, and you've gone through the flow chart and you've done everything on the flow chart and you're kind of left with scratching your head, U501 can be a culprit on the shutdown. So IC501, I should say. So I wanted to leave this off of here just so you can see that IC501 is actually underneath this metal pan, and there's 1, 2, 3 other caps under here as well. So I just haven't put this back on yet. But I think what we'll do now is let's go ahead that we are ready. Let's go ahead and plug this in, turn it on, and see if our fuse stays intact, see if it turns on, see if we get good V+, and proceed from there, because there's no reason to do all this work to it other than what I've already done. There's no reason to do more work to it if it is exploding and blowing stuff up still. So let's just hook it up and see what happens, and cross our fingers and proceed from that point. So here we go. Okay, all hooked up. We got anode, neck, yoke, ground, power. There's no remote board, and I don't have video hooked up because we're only worried about checking to see if it turns on. So I have not turned it on yet. Hopefully our fuse stays intact. We're all set up to read our B+. You read B+ on the G07, of course you go to the frame ground, and then also you go to this side of the B+ resistor right there, and we should read 120, give or take. And then if not, you need to adjust. If you get like 118, 117, whatever, you can turn the B+ pot there and adjust it to 120. So I've already talked about how we've checked the HOT, we've checked the voltage regulator. Usually when F901 goes out, it's something in the flyback circuit or the voltage regulation circuit, the 900 section, I should say. We've already changed out the flyback and the blown up, I think it was what, 421, I don't remember, this resistor right here that was burned up. And that the horizontal frequency was tweaked all the way up and might have been bad. So hopefully we get something here. When I turned it on last time, it just F901 went immediately. So here we go. 1, 2, 3. Whoa! Well, the fuse didn't go. That was an odd... Hold on a second. It's working! Hey, look at that! And I got it right on the money. It just made a very odd noise, which is what scared me. I wasn't used to hearing it go... So I shut that off immediately. Hey, but look at that, 120.7, out freaking standing. The problem now, though, is... I'm going to turn this back off. The problem now is, I hate when this happens because I don't know what the problem was. I don't know. The fuse, when the fuse got taken out after I had already changed the burned up resistor and the flyback. So the problem is, was it in fact the horizontal frequency pot being tweaked all the way to the max? Was it a bad B+ pot? Was it a bad cap? Was it a bad solder? I don't know, and that's kind of really what I hate, because when there's no definitive answer, it's kind of hard to say, oh look, there's the culprit. But that's what the flow chart is for, and that's what if you have a problem with one of these, you can use the flow chart if this video didn't help you. But I'm glad that that works, because now we have a functional G07. We can do the centering. It is vertical. I completely glossed over it. It is vertical. Vertical and horizontal centering pot modification. Fantastic. So I'm going to cut away here and get this installed, and I'll talk about the installation after it's installed, because this video is kind of long already. And then, hopefully if that works, we can get some video signal hooked up, do some tweaking and peeking and what needs to happen here, and we'll call this one a success, and we'll end up with a fully rebuilt, completely rebuilt, reliable, working G07. So let me get this installed, we'll come back and talk about it, get this reinstalled on the tube, get a signal, and do some testing and see what we get. So stand by one moment. Actually, I figure since the G07 does not auto-discharge like most of the Wells-Gardner tubes, or most of the Wells-Gardner chassis, or setups I should say, because the G07 does not auto-discharge, I figured it'd be a good example here to show you how I discharge these monitors if you've never done it or aren't familiar with it. You just go to the frame. You can see I have my black lead here attached to my screwdriver. I'll get that on there a bit better. And it just attaches to your frame there and goes to your screwdriver, and you stick this under your anode cap and you'll hear a nice spark. There you go, and it's now discharged. That's really all there is to it. Actually, I'm going to clip this on here and do it a little bit more here. There we go. It's hard to do this with one hand holding the camera, but try again here, and yeah, nothing. So it's now fully discharged, and as you can see, I can safely take that off of there. And when you have it off, do it one more time, and we got nothing. So there you go. That's how I discharge this. So now, that being said, let's get this back off of here, do the mod, and see what we get. Okay, I got the vertical and horizontal position centering mod installed. It's actually quite simple. There are only a few components to remove, and it turns out, ironically enough, is that one of the components to remove is that resistor I replaced, the R421. That R421 that we had that broke in half, and I replaced with a replacement. It turns out this has to go away completely anyway, and a whole different one gets installed. So That's just how things go. But basically, yeah, the R421 comes out and a different replacement one goes in of a lower rating. I think it goes from, let's see, 12K. It goes from 12K to 6.8 ohms. Was that right? 6.8? 6.8K. Sorry, it goes from 12K to 6.8K. So R421 gets changed out. The two jumpers, of course, get removed. And then there are two resistors and a jumper that come out. So basically just what, 1, 2, 3, 4, 5 components. If we look here now, let's see here. R532 comes out, R507 comes out, R531 comes out, and a jumper gets installed in its place. Then of course the vertical sensor post there is where the jumper was, and of course here's where the other jumper was. Those come out. Then there's another jumper that you have to install that comes with the kit. That goes from the old spot where the vertical center was to the center post. Then you take these two pots and just solder them right to the legs of where the old centering post used to be. That's about it. Take 3 resistors out, put 2 jumpers in, and install the pots. And I've changed out this resistor 421. That's about it. It's very quick and easy. I probably could have done it on camera, but I didn't know what the mod consisted of. So I'm going to go ahead and add these to the list of our parts back here of stuff we have removed or changed out. So let's get it hooked back up to the tube, give it a video signal, and adjust it and see what we can get. Okay, we're all hooked back up, ready to go. We got anode, neck, yoke, ground, power, and video. But I'm not going to turn it on yet because I want to talk about one of the quirks of the G07. Almost every standard JAMA compatible arcade chassis out there only has to use sync on pin 10, the composite sync on pin 10. So basically you have red, green, blue, ground, pin 1, 2, 3, 4, red, green, blue, ground, 1, 2, 3, 4, 5 is empty, 6 is empty, 7 is the key, then you have 8, 9, 10 on the second pin there. Now normally you'd have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all on one long 10 pin connector. Kind of like this, 7, 8, 9, 10, and 10 being the sync, as you can see there. Now the reason I have it hooked up this way is because the G07 has a quirk where you have to hook up the sync and combine it onto pins 9 and 10. So pin 8 would be the ground. You can see there it says J2, J3, and J1. J1 is going to be the ground, a redundant ground from pin 4. And then pin 9 and 10 are going to be the sync. Now you have to hook up the sync to both of those pins. If you try and hook up the sync to only pin 10, like a normal standard K7000 or whatnot, it won't sync. You have to combine pins 9 and 10 together with your sync. So I'm using a jumper here. We're going to hook up our jumper onto pins 9 and 10, just like so. So now we're hooked up across 9 and 10, and then pin 7 there, or pin 8, I'm sorry, pin 8 is empty, that's the ground. 9 and 10 are now combined together and are going to pin 10 here on the generator. So that's how you have to hook up the sync on the G07. It's very touchy. So if you're using a JAMA game, you have to combine pins 9 and 10 on that J2 and J3 there. If you're using a Centipede or Pac-Man or whatever, I don't even think that 3-pin connector is used, and they have the separate sync signals on the main connector there. But I wanted to point that out for future reference. I want to get that off of the B+ resistor there. There we go. Okay, let's turn this on. We know our B+ is good. So let's go ahead and make sure that we get decent signal here and find out. 1, 2, 3. Oh, I should say, I'm sorry, not to get your hopes up there, but I got all of the neckboard pots set to center, and all the regular pots are set to center as well, including our new adjustments here for vertical center and horizontal center. Our 2 new pots here. So, that being said, here we go. Let's try again. 1, 2, 3. That got me again. When I first turn it on, it has a large hum, like something is shorted, and then it kicks to life. So that's just kind of odd, and I always get scared there. So let's try this again. Yes, comes right to life. Okay. That scares me. That's all. Okay, what do we have here? Anything? Anything? Hey! It's alive! Alright, now the adjustment begins. You know what? Let me pause to get this on the tripod, and we'll make some adjustments here to make it easier on you and me. So hang on a second. Okay, so here we go. Let's start with vertical hold, which is this one here. That's good. Now we can adjust our newly installed horizontal center. Oh man, that's awesome. Perfect. Nope, that's not perfect. That's all the way that I can turn it. Oh, see, here we go again. That's all the way that I can turn it. Let's try horizontal frequency. You can shift it with the H-Freak. There we go. Right about there is the limit of where I can have that, but that's still shifted too far that way. Well, gosh darn it, interesting. So we're still plagued with that problem. I can't adjust it anymore because if you see what happens here, the top starts to curl. See how the top curls over? I can't see if I turn this back to roughly, come on, get in there. There we go. If I turn this back to roughly where it's not curled, now it's shifted too far to the left still. Well, let's deal with that later. H position. Can I adjust H position? Yes, I can. Look at that. H size. I'm sorry, V size. V size. V position, V size. Hey, look at that. Let's adjust this again here. A little bit down. A little bit more. That's not bad. Okay, now we need to do our brightness. Roughly there is brightness, contrast, or I'm sorry, focus. Focus, we don't have too much focus control, but we need to turn our color pots down. Let's see, what color is that? That's blue. Green. And red, yeah. Well, I'd kind of like to do this with an actual PCB. But it looks pretty darn good. Yeah, I mean, that's not bad at all. It's shifted slightly. We have a little bit of... We got a little bit of black on this side and a lot of black on this side. So but that's the limit of what I can do, because you can see it's still kind of curved up here. If I adjust it to where the curve goes away completely, there we go. And now it's shifted way over that way. Well, so much for this horizontal centering mod. I'm not too pleased with that. Yeah, that's all the way that it moves to that side. Let me get an actual PCB hooked up, because yeah, there is, you can see here that there is roughly, you know, this much gap on this side and almost nothing on the tiniest little sliver of black. And I've got the horizontal centering pot is adjusted all the way this way, and I can't adjust the horizontal frequency without curling the top like we're used to seeing on every other chassis. Well, let me get an actual PCB hooked up and see if I can make this centered look better, because I don't always trust the test pattern generator. Let me get a real PCB hooked up, see if we can center it, make it look good that way. So hang on a second. Okay, got a real PCB hooked up. Let's see what happens now. Of course, this is my high impact like I always use, so here we go. Okay. What happens now? Do you see what happens, Larry? Do you see what happens, Larry? Well, our yoke is a bit crooked. I can see that our yoke is slightly crooked. But yeah, look at that. Now we are shifted too far that way as opposed to this way. So yeah, I don't like that darn. And we got convergence problems too. That's interesting. So let's see if we can twist the yoke. But Yeah, see, we got, now it's somewhat even. Here, let's do it proper here. Let's do it proper. Where is, there we go. Okay. Diagnostic tests, monitor patterns, crosshatch. Okay, and let's go ahead and see if I can kill the light here. And use my phone. Wow, that convergence is no good. But no, you're not going to be able to tell with the light out. Well, let's plug this back in here, if I can. There we go. We're not going to be able to see. Kill this. Kill that. And that. Okay. Well, now if we zoom in here, we can see that we have, you know, a 1/4 inch on that side, and maybe I don't know, 3/8 on that side. Can't quite tell. But so now with a real PCB, it's different. It's too far that way as opposed to that way. That's why I don't trust that test pattern generator all the time. So let's move it this way a bit. And we'll move our horizontal center back to, there we go. Now we are perfect. Perfectly centered horizontal now. Awesome. Vertical's good, horizontal's good, fantastic. But our yoke is a bit crooked. So let's see if I can shift the old girl. There we go. Hot tamale. That looks pretty good. Tighten her back down. Now let's see if we can fix up this convergence issue here. Is our yoke off here? No, not really. So let's see if we can fix this here. Well, hot damn. Look at that. Gotta move some other ones here. Now, so that side's good. Now we're over here, we're shifted off a bit. Let's move these here. Perfect. Well, I'd say that's pretty good, boys and girls. Yes, indeed, a Rooney. Okay. We are looking good. So now that we are perfectly vertically, we got perfect we got perfect vertical position, perfect horizontal position, perfect horizontal size, vertical size. Let's make sure we can adjust our horizontal size here. Yep, we are squeezing in. Get down in there, you rat bastard. There you go. We are squeezing in. I don't know if you can tell. And now we're going back the opposite way. Hot tamale. Okay, so let's go ahead and kill the light. Escape out of here. And just go ahead and... Oh, we're too bright. That's better. There we go. Focus, you stupid piece of junk. Focus. Green's too low. Let's turn up green a bit. Where'd my light go? There it is. Green. Whoa, too much. And A little blue. There you go. We now have a fully functional, fully rebuilt, ready to last many years to come G07. So that's nice and crisp, looks great. We got our brightness adjusted, we got all of our colors adjusted. It's looking and working fantastic. Awesome. Okay, let's turn our light back on. If I can, there we go. Well, all right, let's take you back off of the deal here. So there you have it. New caps, full reflow, new flyback, B plus readjusted, all new pots, new B plus pot, vertical and horizontal position mod. What else? Was that it? I think so. A replacement F901. Showed you how to do that. And I will link down below all of the replacement parts that I use to get this up and going again. So if you have any issues yourself, you can get some of this stuff and see if that helps you out. And hopefully showing you how to do that F901 solder will keep you from having to use. Easy for me to say. Sorry, like I say, it's been a long day. I had 9 hours of training today, so it's been a long day. Hopefully being able to use that solder technique will keep you from having to use the remote fuse holder, or however you, if that's how you do that in the past or what you do, but I prefer to do it the kind of the correct way. So yeah, there we go. I'll leave this run, make sure it works for a while, and otherwise a successful repair. So thanks for watching. Hopefully you learned something. Got about, I think, maybe 10 or more of these to do. So stay tuned. There's all the old parts. I threw the caps away, unfortunately. Like I say, none of them were leaking or bulging or bad, but I'm sure that, you know, they're 40 years old. It probably didn't help much. So, yeah, like I say, lots more to do. Lots more on the way. Lots more content, like I always say. So, again, I appreciate it. Thank you very much for watching. Thank you very much for subscribing. And stay tuned, and we'll see how everything else turns out from this point on.